Okay, good morning. Welcome to
FamilyMath number 1100.
FamilyMath number 1100. So when I woke up this morning, our friend Ed had posted this interesting math fact on Twitter. The 137,903, 137,904, 195,025 Pythagorean triple triangle has an angle of approximately 44.99979 degrees. It's trying very hard to be isosceles.
Alright.
So that gave me the idea of trying to find other triangles that had angles that were nearly 45 degrees. So they don't have to be right. They don't have to be anything special if you don't want. But we're going to try here to make some triangles that have nearly 45 degree angles.
Okay.
So before we get going into that, tell me what you think might be a good idea for how to do this.
Well, you could take maybe triangles that have 45 degree angles and then modify their angles, or modify the side lengths slightly.
Okay.
So if you, like this triangle has very large side lengths, so if you change like one of them very slightly, it's going to affect the angles just a bit.
Okay. All right. That's interesting. Okay. That's it. I like that idea. Do you have an idea?
Well, you could use approximations for irrational numbers. Like you could make triangles that kind of approximate the square root of 2, or the approximation of square root of 2 multiplied by some powers of 10.
Okay. Make triangles. That approximate the square root of 2 somehow.
Okay.
Sorry, I wasn't paying too much attention. I went a little bit off screen there. All right. There we go. So start with a 45 degree angle and modify, and then somehow make triangles that approximate the square root of 2. So give me an example of a triangle that you think might approximate the square root of 2.
Well, we know like the 1, 1, root 2 triangle.
Okay.
Is our classic isosceles right triangle. So maybe an approximation you could say you could have a 1, 1, and then like a 1.4 triangle.
Ah,
That would
okay.
kind of almost be isosceles. Well, it would be isosceles, but it wouldn't have the 45 degree angles.
All right. Very nice.
And by the way, do they have to be Pythagorean triples?
No.
Okay.
No, you can, so actually interesting example here, your brother just said 1, 1, 1.4. Is that a right triangle?
No, it won't be.
How do you know that it's not a right triangle?
I believe 1.4 is a little less than root 2, and you still have the other side lengths that are the same, so...
Mm-hmm. You can square 1 squared plus 1 squared is 2, 1.4 squared is 1.96.
Uh-huh.
So you're not quite a Pythagorean triple.
Mm-hmm. These legs just get scrunched in a little bit.
Okay, so interesting. So is the equal angles, are they going to be less than or greater than 45 degrees?
I think greater than 45.
How come?
Because if you moved in the legs all the way, they would meet in the middle and make 90 degree angles.
Mm-hmm.
So as you move them in, the angles they gradually get larger.
Okay.
If you move them out, you would eventually get a flat, just a line and 0 degree angles.
All right. Do you have a different way of thinking about that? Maybe. Why do these angles are bigger than 45 degrees compared to this one?
I'd just say that the hypotenuse is less here. So I guess maybe just kind of by the triangle inequality. Well, not even by the triangle. So this distance is less. So this angle is going to be less, which means that these angles have to be more.
Yeah, nice. Both of those ways are really good ways of thinking about it. Just to summarize the second way, just real quick before we move on to the next video. These two angles stay the same. This angle is shrinking, so that means those ones have to be grown.
Yeah.
Good. Both are great ways of thinking about it. All right, let's go to the next angle, and we'll start with your idea of modifying something that we already know is 45 degrees.
Okay.